Hello and welcome to Lesson 3, Area of a Rhombus and Kite. Our objectives are to find the area of a rhombus and kite and to use Pythagorean theorem and area to solve for missing links. I include the rhombus and the kite together because you can use the same formula to calculate the area whether it's a rhombus or a kite. So let's explore those shapes. Here's a kite and here's a rhombus. They look very similar. The only difference between the two is that a rhombus has all four sides that are congruent. So I could draw a congruency mark here, 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 and here. Very similar to a square, except that a square has 90-degree angles where a rhombus doesn't. So I know I have all four sides are congruent. But I can use the formula that we're about to look at. A kite, on the other hand, has two sets of sides that are congruent. This side is congruent to this side, and this side is congruent to this side. Now let's think about what we have here. We actually have two angles, and I can actually draw in, I'll do that in green, this top triangle right here, and then I have a bottom triangle, which I will draw in pink down here. Now think about your understanding of triangles. Let's look at this green triangle. In this green triangle, if both these legs are congruent, what does that say about both these angles? Both these angles are also congruent. We have an isosceles triangle. Same thing with the bottom. Both these legs are congruent, so both these angles are going to be congruent because we have an isosceles triangle there. So a kite is really two isosceles triangles together. Now, one thing that you need to know is that each diagonal splits the other the long diagonal, I should say, splits the other diagonal into two congruent pieces. So, if I was going to put some marks on this, I could say that this segment is always going to be congruent to this segment. And that's an important property that you'll need to know in order to help you to find missing measures. Now, the other diagonal obviously does not always split the long diagonal into two congruent pieces. It does, however, split the angles into two congruent angles, here and here, and here and here. That's not going to be as important for our lesson today as knowing that the long diagonal splits the short diagonal into two congruent segments. Let's look at our equation. I've changed these from base 1, base 2 to diagonal 1, diagonal 2 to more closely represent a kite in a rhombus. Now let's think about this. If we look at this top green triangle, now the diagonals are the dotted lines that run through the middle of the kite. So if you look at the green triangle, we have a little dot here, a portion of it. That would represent our height if we were finding the area. And the other diagonal would represent the base. On the pink triangle, the other portion of that diagonal would represent the height, and we would have the same base. So if you put those two equations together, we really have the equation for two triangles connected. We have diagonal 1, which could be the short one, diagonal 2, which could be the long one, so the two heights, but one is a height and one is a base, divided by 2. So it's very easy to remember if you think of it as a triangle. And that would hold true for a rhombus as well. So remember, the only difference between a rhombus and a kite is that a rhombus has all four sides that are the same, that are congruent. But we will calculate area using the same equation. Let's do an example. In the first equation, we are given the two diagonals. This one is 6, this one is 8.4. In order to calculate the area, remember that we have to multiply both diagonals together. So we would have 6 times 8.4, and then we would divide by 2. Now because this is all multiplication division, it doesn't matter what we do first. We could do 6 divided by 2, and then multiply that result by 8.4, or we could multiply our numerator and then divide by 2, which is what I'm going to go ahead and do right now. So we have 6 times 8.4 to give us 50.4, and then when I do 2, I get an answer of 25.2 centimeters squared. And this one should say centimeters. Let's go ahead and look at another example. In this example, we also want to find the area, but we're not given all the information. We are missing some pieces that we're going to have to figure out. Well, this segment here is 20, so remember what I told you. The long diagonal bisects the short diagonal. So we know this is 20. So we know that one diagonal, we'll call that diagonal 1, is equal to 20. But we don't know what diagonal 2 is yet. We're going to have to figure that out. That is going to be our question. Okay, well, what else do we have? What else do we know? Well, since we know that the diagonals, this diagonal bisects this diagonal and they're perpendicular, these are little right triangles. If we notice that these are right triangles, we know we can do Pythagorean theorem to find missing links. Well, this is 25. This is congruent. This is also 25. If this is 35, then this side is also 35. So let's use this information to find these pieces here. In this first triangle, the hypotenuse is 25 and one of the legs is 20. And this is what we are trying to find. I'll mark it with an X. Let's do some math and figure this out. All right, we have 20 squared, we'll call that our a squared, plus b squared, we'll say that's x squared, is equal to c squared, which is the 25. If we simplify, we end up with 400 plus x squared equals 625. Subtracting 400 from both sides, I get 225. And then if we take the square root, remember that's how we solve x squared, is we need to take the square root of both sides to get rid of the squared, and we end up with x is equal to, and if you don't know what the square root is, do it on your calculator, and you'll find that it's equal to 15. This piece here is equal to 15. Well, I've now got partially of a diagonal. I have a partial piece, I should say, of the diagonal. I need to now get this long piece. Well, how can I do that? Remember again that this triangle down here is also a right triangle, of which I have a hypotenuse of 35 and a side or a leg of 20. So we'll call this y here, and we'll go ahead and do Pythagorean theorem again in order to solve for that. In this case, we'll say that a is then 20, so a squared plus b squared, we labeled that as y, has to equal 35 squared. Again, we will simplify. 20 squared is 400, and 35 squared, and then in this case I would multiply 35 times 35 to get 35 squared, is 1225. Then I would subtract 400 from both sides, and I would end up with y squared is equal to 825. I definitely can't do this in my head, so I'm going to take the square root in my calculator. The square root of 825 comes to 28.7. So that means that this piece, or this portion of the diagonal, is now 28.7. But having these two gives me enough information to then find and solve for my second diagonal down here. If I add 28.7 plus 15, I should get 43.7. I'm now ready to find the area of this kite. Remember, it's diagonal 1, which we got 43.7, times diagonal 2, which is 20 plus 20. That gives us 40, all divided by 2. Now this time I am going to simplify the 40 and the 2. I'm going to take the 2 into the 40 and get 20 just to make it easier for myself so I don't have such big numbers. Now all I have to do is take 43.7 times the 20 and I get 874, and I'm going to round to the 0.5. And this is units squared again because I'm finding area. Okay, in this example, we didn't have all the information, but we used the fact that we have 4 right triangles to help us find pieces, to help us find missing segments the lengths of missing segments. So always keep that in the back of your head. Let's try a different example. In this example, we are given one diagonal as 17, and then we're just given this piece as 8. This is an easy one. You already know how to do that. If this is 8, this is also 8, and we have enough information here to find the area. So diagonal 1 is 17. Diagonal 2 is going to be 8 plus 8, which is 16, divided by 2. And again, I'm going to simplify the 16 and the 2 because those are divisible pretty nicely. And I get 8. And all I have to do now is multiply the 8 times the 17 to get 136 centimeters squared. So a little bit simpler one, but again, taking the information we know about a kite in order to help us mark segments that we don't know. All right, let's move on to some word problems. We have a couple of these examples and then we'll be finished with this lesson. In this example, we are finding a missing measure. A kite has an area of 18 centimeters squared. One diagonal measures 4 centimeters. Find the measure of the other diagonal. Well, let's go ahead and make a kite and then label. So here's our kite. If we label our diagonals, we have one diagonal here and one diagonal, the short one there. We know that the area, the whole thing, is equal to 18 centimeters squared. One diagonal measures 4 centimeters. So I'll just assume that the short one is 4. So from here to here is 4. And what we need to find is the length of this long diagonal. So how do we do that? Well, the first thing I always do is I write the equation. So we have diagonal 1 times diagonal 2 divided by 2. And then we just fill in the information that we know. What's given? The area is 18. Plug that in for A. We do know one diagonal is 4, so we'll plug that in for that diagonal, and then we're just left with only one variable here. Well, now we can simplify. 4 divided by 2 is just 2. So we're left with 18 equals 2D, and now you can see how to solve. We just use division to get 9. The other diagonal then would be 9 centimeters. So we could put that right in here, 9 centimeters. Let's try one more word problem. In this example, a kite has an area of 240 centimeters, or inches squared, I should say. So I'm drawing my kite, and I've got my area, which is 240 inches squared. Then it says, determine the length of the diagonals if one diagonal is 2 times as long as the other. So we're not really given any numbers, we just know how they are in relation to each other. Well, that means we need to call one diagonal x, so obviously the short one would have to be x, and then the other diagonal is 2 times as long as that, 2 times x. And that's how I can label my kite. It would be the same thing as if I said one diagonal is 3 times as long as the other. Then this would be 3x, or 4 times as long. So, just like before, we're going to take our information and we're going to replace the variables here in our equation with the information that's given. Area. We know the area, it's 240. And we know the diagonals. One is x and the other is 2x. And then we can divide by 2. So what I'm going to do is I'm going to multiply x times 2x and get 2x squared. 2 times 1 is 2, and x times x is x squared, divided by 2. In this situation, I'll simplify by eliminating my 2's. 2 goes into 2 once. And I'm then just left with x squared equals 240. You know how to solve this. All we need to do is take the square root of both sides. So we would use our calculator once more to take the square root of 240, and we would be left with x is equal to 15.5 inches. And now we have solved for x. X is 15.5. It says, determine the length of the diagonals. So we found one of the diagonals. The other diagonal is 2 times 15.5. So what is that? Well, that would be 31. 2 times 15.5 is going to be equal to 31 inches. And that concludes our lesson today on finding the area of a rhombus or a kite. So at this point, hopefully you will continue to use Pythagorean theorem to help you solve missing pieces, as well as work backwards to find the length of a diagonal if you know the area.